Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au. Welcome everybody to this webinar, Managing Saline Groundwater, and it's presented by Andrew Telfer from Water Technology. We apologise for the preceding few minutes. Normally we open the lines long enough for people to log in, but this whole state of South Australia has had a catastrophic fire warning, and we've lost power a couple of times, but we're back on deck now on the 1:30 in Adelaide, 2 o'clock in Sydney time. Hope you're all joining us as we speak. My name's Trevor Pillar. I'm the National Partnerships Manager here at IceWarm and the Chair of the Australian Water School webinars. It's really great to have you all here today, and there's hundreds spread across the globe, and that spread is on the screen right now. You can see from one side of the world to the other. Thank you so much for joining us, and we hope we'll have we know we're going to have a fantastic discussion with this many people, and Andrew and Assistant Alison Charles, another hydrogeologist who works with Andrew in Water Technology. Right, well, what's happening up front? You can see this month there's 6 things there, free webinars, online courses. I won't go into each one, but each month we offer this level of training right across the water sector, and we invite you to go to our website, Twitter feed, and pick up on what is actually happening here. There is a lot happening, as you can see. But for right now, Andrew, come on screen and let's have a chat. Andrew's a senior principal hydrogeologist with Water Technology, a water consulting firm here in Australia. Andrew and his team have designed and delivered large-scale groundwater management solutions across the Murray-Darling Basin in Australia for over 35 years. So it's a wealth of experience. Welcome, Andrew. Nice to have you. And you're presenting from Adelaide in South Australia?
Yes, thank you, Trevor. A beautiful, balmy 42 degrees outside.
42.
And hot
north
wind.
Power failures here for the last hour or so. Thank you for putting up with all the back and forth and the changing of computers to get this working. It's great that you're on board and working now. And Alison's also with you. I understand Alison Charles is nearby helping.
Fingers poised over the keypad.
Fantastic. So that's a big asset in this webinar. I encourage everybody to take advantage of this. Two hydrogeologists who have done a lot of work in salinity management are ready to talk with you and discuss with you, both on screen and on written Q&A line. That's fantastic. Thank you, Alison. So she'll be working with the Q&A line, and that's terrific. And I can see many online now. Thank you for joining us, everybody. I do get interested to see why people like yourself, Andrew, get so tied up, intense, and working strongly. I shouldn't use those words, but what I mean to say is that you've been known for a long time as a professional in the salinity management area. Just would be interested to see where you're coming from. What drives you to it? What motivates you?
Yeah, good question. I grew up in the country in the Northern Flinders Ranges here in South Australia, arid landscape. So geology was pretty evident. So I studied geology at university and got interested in groundwater at the end of that period, at the end of uni. I've done nothing else ever since. And as luck would have it, one of my first jobs was to design one of the first large salt and deception schemes in the Murray-Darling Basin, and I've been doing it ever since. It's good fun. It's pretty interesting work, good applied science, problem solving on a large scale.
And when you say done nothing else, I mean, this is a wide, broad set of disciplines. You know, the science isn't just simply groundwater science. It covers pumps, and it covers water behaviour and fluid hydraulics, all sorts of things, chemistry. You're not sitting in a small space. It's a quite rather large space.
Yeah, that's right. It's I say later on, it's about constraining the solution. There is no right answer. There's a suite of solutions that will work, and what you've got to do is use multiple lines of evidence to constrain that solution space until you come up with something that's economically feasible and practical and delivers the outcomes that the clients are looking for. So it's problem solving on a large scale, which is a pretty interesting thing to be doing for 30 years of your career.
Yep, no, fantastic. And the Murray-Darling Basin is a huge area. Like what we're talking about here, a seventh of
Oh,
the Australian landscape, something like that, large.
yeah, it's 600 kilometres across. It's the Murray Basin itself is roughly circular and about 600 kilometres
Yeah.
in diameter.
Massive,
Yeah.
yeah. No. Well, look, let's not take any more time. There were some polls for everybody. I think no, we didn't get to those polls. I don't think. Let's look at that a bit later. But let's get right into this presentation now. And can I encourage everybody? Do keep your questions coming or discussion points coming. Any comments you'd like to make, and we'll pick them up as Andrew goes through where they're relevant to what he's saying. I won't interrupt every 5 minutes, Andrew. But if there's something relevant, I will.
Feel free.
Otherwise, we'll keep. No worries, thank you. Otherwise, we'll keep the questions to when you finish. But great to have you, Andrew, and handing right over to you now.
Okay, bear with me while I get this organised.
Right over to you.
That looks good from your end, right?
Fantastic, cool. Perfect. Yep, fantastic.
The cover photo here, the photo on the front slide here is of salt crystals, which were in a saline pool that I've been working on recently in the Murray Basin. These crystals are 5 to 10 centimetres in diameter. It's a very large saline groundwater expressing at the surface. It's a saline pool. So this is kind of the visual expression of what I've been working on in salinity over the last 35 years, I suppose. Trevor asked where I came from. I was going to talk about that. So this is the country that I grew up in the Flinders Ranges. So we've got part of the Wilpena Pound is actually just poking up here, and the Elder Range. It's a very arid landscape, and this is taken from on top of a hill. The bottom slide here is looking the other way. You can see it's quite an arid landscape, and you can probably see what the attraction of geology was to a young fellow growing up in this country. And you can probably also see what the attraction of water is to a young fellow growing up in this country. So yeah, that's a little bit of my background. This presentation, look, as we've been saying, I've been fortunate to spend over 30 years working on one class of problem, or largely on one class of problem. Large-scale management of saline groundwater for water quality, and more recently for ecological improvement. I can't hope to distill all of that down into 30 minutes. And I'm aware that we've got an international audience, so I'd like to start with an overview of the Australian salinity context. Australia is a very salty country, and then focus in on the Murray-Darling Basin context, and then look at the approaches that we've used in designing large well fields, and finish with a couple of examples of salinity and ecological outcomes that are derived from saline groundwater management. I'm not going to go into detail. Perhaps if there's a need, we can schedule something around specific details. But just a heads up that I won't be talking in a lot of detail. I'll be talking more broadly about the context and the approach, not necessarily the details of any one design. I work for Water Technology. I'm a director in Water Technology. We're a 100-strong water-related consulting company, surface water, groundwater, coastal and waterway management across Australia. We deliver solutions for a whole range of clients: government, federal government, state government, local government, private individuals, and private companies. We've got a lot of specialised skills. We are passionate about what we do and how we do it, and we're interested in the outcomes that we're delivering, trying to make the best outcomes that we can within the constraints that we have available, best outcomes for the client and for the environment within the constraints that we have available. I must acknowledge the pivotal role that all of these, mostly government departments, have played in my career. or SA Water is a water utility here in South Australia. We've done a lot of the work on the salt interception scheme design. I used to work for them back a couple of decades ago. They have done a lot of work in managing the construction of the salt interception schemes, and I've been engaged with them over the last, well, both employed by and engaged by them over the last 30 odd years. The Murray-Darling Basin Authority is a large organisation based in Canberra whose remit is to manage the water resources in the Murray-Darling Basin, and the funding for all of the salt interception scheme work comes from the Murray-Darling Basin through to the partner states, and in South Australia to SA Water, in Victoria to Golden Murray Water, for the construction of salt interception schemes and other works to address salinity and ecological management outcomes. The Mallee Catchment Management Authority in northwest Victoria, we've done a lot of work in there, and that will become obvious why a little bit later. Working with New South Wales Government and DELP in Victoria as the manager of water accountability, and in South Australia, particularly in the last 5 years or more, the Department of Environment and Water, as they are now, we've been engaged with them on looking at water management, groundwater management in relation to surface water structures on the floodplain that have the capacity to mobilise salt. So we've been looking at maximising the ecological benefits of the surface watering and minimising the ecological disbenefits of watering that occur through groundwater processes. So there are a lot of people, there are a lot of knowledgeable people in these organisations. I don't profess to be speaking for any of those, but must express my you know, I've been working with them for a long time, and I'm grateful to their support over the years. So, onto the presentation. So, salt in the Australian context. Australia is a very saline country, as I was saying. Lake Eyre in South Australia is a terminal lake. It's below sea level in the middle of Australia, very low, 100 more kilometres long. Why is Australia such a saline environment? This is the rainfall, average rainfall from 61 to 90, which probably precedes the any effects of climate change. So these numbers are probably a bit higher than they currently are. We can see here that above 1500, there's very little of Australia that has more than 1500 millimetres of rain per year, and there are large slabs of Australia that have less than 300 millimetres or 12 inches in the old money. So Australia's a pretty, it's a low rainfall environment, and if we look at evaporation, we can see here that the potential evaporation or total evaporation rates are quite high, 4 metres over here, and Telfer here is a gold mine which unfortunately is no relation. Would like it to be, but not. So very high rates of evaporation here. So Lake Eyre that we were looking at before is in this neck of the woods. So high evaporation rates. So before we're looking at rainfall of 300 millimetres across here, and we've got an order of magnitude more evaporation in the centre and across the west of Australia. Lower evaporation rates around the edges here. If we look at topography, we can see here those high evaporation rates, and Lake Eyre again is in here. So this is a very low-lying part of Australia. It drains all of the water from this side of the Great Dividing Range, which is this zone of red here. All of that flows inland the northern quadrant here flows down into the terminal lakes down here, which include Lake Eyre. And as I said, they're below sea level, not connected to the sea. So there's a constant accumulation of water and evaporation of water in there. Now the Murray Basin here is quite evident as being a low-lying area in the landscape as well on a national scale. And the Darling Basin so the Murray Basin is this roughly circular patch here, and the Darling, which is a groundwater basin as well as a surface water basin. The Darling Basin, the other half of the Murray-Darling Basin, is a surface water catchment that drains in through to the Murray River, and the Murray River course follows the state boundary line through here. So both the Lake Eyre Basin and the Murray Basin are low-lying, are relatively low-lying topographically within the Australian continent. And if you look at the groundwater flow systems, there are large-scale, regional groundwater flow systems in here and in the Murray Basin, and across up through here. So this part of Australia is 4 billion years old, 4.2 I think, and again up here, this little patch up here, very, very old, the oldest rocks in the world, and Australia has accreted onto these rocks from the east. So Australia gets younger as you go this way. But large-scale flow systems here in the Murray Basin and here in these in the Eyre Basin, in these low elevation parts of Australia. So it's probably no surprise that we end up with saline groundwater in this part. So this red here outline is, you'll see this a few times, this is you put roughly the extent of the Murray-Darling Basin. It's not exact, but it gives an indication of where it is. So we have saline groundwater across a lot of Australia, the south, and up here into the Northern Territory, Western Australia. And if we look at the salt lakes, this is a map from Jim Bowler, and the black here outlines where the salt lakes are in Australia, or the larger ones anyway. And if we think back to or if we look at the topography here, we can see all these lakes here are around the terminal, in this terminal system in the Lake Eyre Basin, and some other local systems through here. There's a number of salt lakes in through the Murray Basin, in through here, these little black dots here. Lake Tyrrell is harvested for salt. It's a pink lake, it's a pink salt lake, so it attracts quite a lot of interest from international tourists. But these salt lakes over here are more developed in local flow systems. So unlike most other continents, Australia's large, low-lying, dominated by evaporation over rainfall, and has accumulated, and it's a very old continent. The rocks to the east are Triassic and Jurassic, and then there's a little bit of tertiary in places, but otherwise it's Jurassic or older, and it's low lying, and salt has accumulated. So yes, we have an abundance of salt, more than you can poke a stick at, as they say. So I'd like to then take a little look at salinity in the Murray-Darling Basin. And here's an expression of saline groundwater coming to the surface. This is where those salt crystals were in the first slide. And what we see is salt coming to the surface. There are economic disbenefits from this. There are ecological disbenefits from this, and there are social disbenefits from this salt coming to the surface. The salinity in the Murray-Darling Basin, it was, I guess we really started with the economic impacts, trying to mitigate social as well, because it was really drinking water quality that started to that drove the impetus into managing groundwater to improve water quality. But I'll come back to that in a minute. So over here, again, the Murray-Darling Basin. So here's the Murray-Darling drainage outlined on a Google Earth image of Australia, and here's in the green line here is the Murray Geological Basin. And what you can probably start to pick up from here is that this is all, there's not much green out here in a lot of this. There are the more productive agricultural areas around the margin of the Murray-Darling Basin and along the River Murray. You can see that's a large red gum forest, native woodlands on the river itself. Some more in here, so Barmer, and some more forests in through here. And then we get irrigation along the extent of the River Murray. And over here on the right, you can see this Murray-Darling Basin, or the Murray-Darling Drainage Basin outline here, and the yellow patches here are irrigation areas, the major irrigation areas. So in the upland areas, there's quite a lot of irrigation. So the Barmer choke here, the Barmer forest here is on this corner in here. There's quite a lot of irrigation through here. These are all alluvial fans coming off the highlands, off the Great Dividing Range, uniformly, low slope, sloping out to the west. The Murray River rises here in the southeast of the Murray Basin, drains out through all this dry country, out through here, and then down to out to the sea here. And there's irrigation development along here, and quite a patch in here which isn't showing up that well in Sunraysia, and irrigation along here. So the River Murray has provided a significant water source for irrigation ever since the early 1900s. The River Murray is also one of the major water supplies the major secure water supply in South Australia. South Australia is noted as being the driest state in the driest inhabited continent, and Antarctica is drier but not inhabited. So South Australia is the driest state in the driest continent, and water is a scarce resource. And so Adelaide, which is a city of 1 million or more here, which is where we're broadcasting from, derives its water from pipelines from the River Murray, or part of its water, up to 90% or more in some years, from the River Murray. So the River Murray is a major water supply as well as an irrigation water supply. The Murray-Darling Basin is the largest river system in Australia. 3 million people have access to clean drinking water from the basin. Salinity levels, so as I was saying before, one of the issues that drove the salinity management of the Murray-Darling Basin was that salinity levels at Morgan, which was a reference site, which is just upstream of the major offtakes to Adelaide and to country South Australia. I mean, this water goes all the way up here and around the corner to Whyalla, or in fact down to Port Lincoln now, water from the Murray River, and it's piped down this way as well. So there's a very large network of country towns that are supplied from the River Murray. But the salinity here was starting to exceed WHO guideline levels, and the Murray Basin and the Murray-Darling Basin Authority and the states that go to form that organisation set a target level of 800 EC, electrical conductivity units, at Morgan. So Morgan is a reference site, and I'll show you a little bit later that these targets were being exceeded, and that was one of the impetuses for this program of works, which has been really quite successful to stop salt getting into the river. The Murray-Darling Basin is the food bowl of Australia, 24 billion in agricultural production. it's, as I was saying, it's broad and it was flat. So if we assume that the basin is a metre wide, to give you some context of this Murray Basin, Murray Geological Basin, hydrogeological basin, if we assume the basin is a metre wide, then at its thickest, it is no more than a millimetre thick. So it's a very thin veneer on this old landscape. It's a very thin veneer in natural scale, and it's essentially a closed system. There's a reef of, or there's basement high, which outcrops all the way through here, and subcrops under the Murray Basin here. So there's actually only a very small thickness of aquifer that can discharge over this basement high and out into the or toward the sea. And this means that all of the water and salt that comes into this basin and into the groundwater systems, pretty much that doesn't get evaporated, which is a large volume, but the remainder, which is going to be increased in salinity, the remainder of that water discharges into the River Murray. And so the River Murray is actually a natural drain of this saline groundwater. And I'll show you a bit more of the salinity patterns in this lower reaches of the river in a minute. So this discharge, so this river, which is a source of water for irrigation and for well over 1 million people, is naturally a drain for saline groundwater, and that groundwater can exceed seawater salinity. So those two things are not pulling in the same direction in terms of management, and we'll see a little bit of that in a minute. I was talking about the basin is wide and flat, so if we expand out the natural scale some 100 times, we get a broad overview of an east-west cross-section through the Murray Basin. What we've largely got here is in green is a fluvial system derived from erosion of the highlands to the east and south of the Murray Basin. Sands, gravels, silts discharging into the Murray Basin, and then we have here a marine incursion in Oligocene-Miocene marine incursion, and this incursion happened, or this high stand happened all around the world, and the Floridan aquifer in America, there's Miocene aquifers in India and Sri Lanka. This sequence is roughly the same across the world. It's a marine limestone, not particularly deep water, 40, 80 metre deep maybe. And in between this fluvial system and the marine system is like a coastal low energy environment, which is clays. And so as the marine transgression came in between the sea and the land was a broad zone of a low energy environment depositing clays and silts. So this clay wraps around the marine incursion and over the top. There was another smaller marine incursion in the Pliocene and some more fluvial, and this is fluvial through here and marine out to the west. More fluvial systems here, mostly channel sands within a clay matrix. So being hydrogeologists, we've subdivided up this very thin veneer into this and more detail. But as you can see here, the flow lines show that water's coming in from the east. It comes through in the Renmark group system. It leaks up into the Murray group system because it can't get out to the west. Leaks up into the Murray group system and up and into the River Murray, and the small amounts that don't get evaporated come out and into the River Murray. So that's the natural system, and that's the genesis of the salt problem. And then the irrigation on top of on top of this natural system, takes water from the River Murray, fresh water, puts it over the landscape. A fraction of that water then goes down to the groundwater system, and that mobilises the salt water that's already in the groundwater system, and that water eventually finds its way back to the River Murray, sometimes within a matter of years to decades. Sometimes it's going to be 1,000 years, but eventually all of that water going in will come back out into the River Murray. And so the work that I've been doing is myself and others has been trying to effectively manage that discharge of saline groundwater into the River Murray. I think have covered off on that. Look, let me go back, sorry. I am not an authority on policy and strategy. I have a working knowledge of it in relation to the work that I do, and there are people in the MDBA and in the state organisations, Department of for Water and Department of Water in New South Wales, who are much better able to articulate detail of policy if you have interest in that area. And I'd recommend that you try and contact people there. We might be able to help you with contacts if you need. In 1989, just a few key high points here. In 1989, the salinity and drainage strategy was set up, and I see that time is moving on. Salinity and drainage strategy was set up and as a framework for joint actions to manage river salinity. The Basin salinity management strategy was set up to cover the period 2001 and 2015, and this is where it again reiterated the target at Morgan of keeping the River Murray salinity at Morgan below 800 EC 95% of the time. And it set up a salinity registers, so a system of debits and credits where any salt added into the landscape or added into the river is counted as a debit. Any salt removed from the river, i.e. by groundwater interception schemes, is a credit. And those registers are recorded at the state level. And that the Basin Salinity Management Strategy 2030 is an update on all of this, and maintaining the cap on salinity through existing salinity targets and accountability framework. And there's also responsive, looking at how to manage the salt interception schemes better.
Can I just maybe pause for a tick there, Andrew?
Sure.
That brings us to about, we're about 25 minutes from the end, and I do want to include as many people, their comments
sure.
as possible. It's just a good spot to pick up on Bruce Mundy. Thank you very much, Bruce, for your comments and question there. What do you think, Andrew? Should we?
Yeah. My apologies. I've been...
No, it's set a very good foundation, but maybe we're going to have to take the highlights of the next set of. I'm looking down at the PowerPoints to come. Maybe pick the highlights of them. But sure. Would you mind if I had a look at Bruce's a very comprehensive comment and Alison's very comprehensive response? Is that a good thing to do?
I reckon.
Bruce, thanks for your question. The drought throughout much of the Murray-Darling Basin would have reduced recharge to local groundwater systems, and so presumably reduced saline discharge to salt-affected areas. Is this so? Similarly, I presume there's also been a reduced discharge of saline groundwater directly to the Murray and Murrumbidgee. If so, does this mean that there is a huge slug of salt waiting to be discharged into the river systems when the drought breaks? I highlight that, and everybody, you can pick that up on your Q&A. If you hit the Q&A icon at the bottom, you're about to pick up what Bruce is saying here. Quite perceptive here, and also Alison's really good response. Where to go with Andrew? I'll leave it in your hands. Whether we for the sake of the recording, it might be useful for others to hear what Alison has said, and yourself as well. Well, maybe, hi Bruce. Alison says, hi Bruce, the MDBA, Murray-Darling Basin, commissioned some work on this following the end of the Millennium Drought. See the link below for more info. The reason I'm reading this, sorry everyone, just to remind everybody that what we can see on the screen, the recording, won't appear in the recording, and most people come back to this recording later. So I'll keep going with Alison's response. There have been a range of salt load reduction mechanisms during the drought, including drought-induced salt storage in floodplains, improved irrigation, salt interception schemes, and low salinity surface water inputs from the Hume Dam. Overall, the report concluded that from the analysis of salt load patterns over the last 30 years, that the Millennium Drought was unlikely to significantly increase post-flood salt inputs. The post-flood salinity regime and peak salinity levels would, however, be affected by flood magnitude and management of flood recessions. So that's a fantastic overview, Alison. Thanks. I'll leave it with you, Andrew.
No, Alison's done a great job there. That was an interesting piece of work that we did, and I can touch on that a little bit. Yeah, the rates of salt coming in are, in terms of flow volumes, are relatively low, are quite small, but it's the high salinity that's the killer. So it's relatively small volumes of high salinity water, and they're not particularly affected by drought. They are to some extent, but it's a perturbation on the fluxes, not a cessation of the fluxes.
Yep. There's another one in the chat line by Cara Jacques. Maybe if we could use the Q&A, not the chat line, but thank you, Cara, for your question here. This is a good one. Has consideration been made to the reduction of groundwater to the Murray from the original Snowy Mountains scheme? And what are the thoughts about the next scheme?
Look, as I said before, I'm not really a policy kind of guy. There has undoubtedly been consideration of that, but there is a very large amount of irrigation infrastructure built up on the back of, and communities built up on the back of the Snowy Mountains water coming west, and the reaction to cessation of that flow would be strong and sustained. I would suggest. Snowy 2 sounds like a good idea. I'm not really across any of the detail of it.
I'll pick up a couple here from Adnan Mohammed. Are there any impacts of regional flow due to recharge from the New South Wales and Victoria to reduce the salinity? You might see it in that open question there.
Yes, I'm just trying to. There's the Q&As, right. From Adnan, are there any impacts of regional flow due to recharge from New South Wales and Victorian high? Certainly the high rainfall, the water quality around the margins of the basin is pretty good, no doubt. And the margins at the eastern and southern margins of the basin obtain good quality groundwater recharge from the highlands. But that water becomes progressively more saline as you move down the very long flow paths that occur.
Now, we're going to have to keep these answers short, but thanks a lot, Andrew. I do want to pick up one if I can before we get back into the presentation. Grant Stoner has said the Murray River can get rid of some of the salt from the basin, although much still remains. I'm wondering if Andrew could provide some advice on the disposal of salt from a totally closed basin, such as the Western Australian wheat belt in the zone of ancient drainage.
Disposal of salt is difficult. You've got to remove it somehow. In the Murray Basin, it's a reallocation of the salt or a re-storage of the salt back into the landscape or in the groundwater system. If you want to get rid of the salt, you've got to effectively truck it out. So you've got to move it out somehow, concentrate it up and move it out.
Yep. Let's press on with thanks so much, Grant. Thanks, Adnan and Bruce. There's a lot more questions coming in, but I think we just get straight back into this presentation. We've got about just under 20 minutes before the hour is up. Why don't we just hop back into the presentation. Is that all right with you, Andrew? Yep.
I shall rattle on.
Keep the questions coming, everybody. Keep the questions coming. And the other thing is review the answered columns. You'll see Alison's very kindly helped us today and inputting her extensive experience. I understand she helped put the presentation together with you, Andrew. That's
absolutely
a good experience going on there.
Alison and I have been working together for 13 years.
Fantastic.
On salt interception for almost all of that time.
Yep.
Salinity, so I will touch on a couple of things here. So this is
just one reminder to everyone:
Sure.
when you see a question on the Q&A board, if you think it important to you, hit the upvote button, and we'll know which questions are important to everybody. That will help us prioritise the questions really well. Yeah, that's all I want to say. But yeah, thank you. Upvote the other questions here.
Alison's answer to one of the previous questions is really what these graphs are about. What we found in that study of the River Murray salinity was that most of the exceedances of the 800 EC, so this is a graph of flow and salinity at Morgan, which is an excerpt of this lower line here. So high flows, low salinity, low flows, high salinity. And when we blow it up, the exceedances of 800 EC are mostly in this area here where we're down at very low flows. And this is because there's a lack of dilution for the salt that's coming in, like that background input of salt. And the remainder in here are before, almost all immediately before or after flow, after these low flows. And there are reasons for that. So we found in that study that there was that it was low flows and the back. Oh, what's going on? There we go. So we do a lot of so looking at the salt interception schemes. They're large-scale pumping to prevent saline groundwater entering the River Murray. So this is a cross-section through a bore field at one of the bore fields at Woolpunda. Each of these is a production bore, and here's the water table in between them. And this is really the essence of the design before we'd constructed the scheme. So this is the river level here in the green dotted line. Before we constructed the Woolpunda scheme, and this was what I started working on in 1987, my first scheme. So the groundwater levels were up here. So we designed a bore field to pull the groundwater levels at the midpoint between the production bores, each of these production bores, pull these groundwater levels down below river level. So the groundwater was no longer discharging to the river, it was discharging into the bores and then being pumped inland and evaporated, some proportion of that water being evaporated in a disposal basin and some proportion going back into the groundwater system. So salt interception schemes are large bore fields moving water away from the river and into the and floodplain and back inland for evaporative concentration and groundwater storage. It's a key component of the MDBA salinity management strategies because it could be implemented relatively quickly, and it has been tremendously successful. It addresses irrigation and natural saline groundwater systems, and it's really bore field pipeline disposal option. So, and we've addressed all three of those, but mostly the bore fields and pipelines, with a KPI of in-stream reduction. 18 interception schemes, 500,000 tonnes of salt prevented from getting into the river, 500,000 tonnes of salt per annum getting into the river. The schemes are located here in the bottom half of the Murray Basin, and we've worked on pretty much all of those, designed 3/4 of these in the red box and worked on them all. And to give you an idea of size, so the red dots here are individual bores. So we'll back to the Murray Basin. So we're in this neck of the woods here toward the southern end. Lots of bores along this reach of the river, quite saline, and I'll show you salinity data in a minute. Let me go back. There's a bore field through here. This bore field is well and truly constructed, and that little arc there is meant to be around here, and that bore field has just recently been constructed, not yet operational. Another one here, another 4 bores here. Mildura Mabine was refurbished a few years ago, and Mallee Cliffs here. So a large number of bores. Then that's about 550 kilometres of river length, east-west extent of 240 kilometres because the river snakes around, 200 bores, 300 kilometres of pipeline, pumping 20 gigalitres per annum, intercepting, or the salt flux pumped is 500,000 tonnes and close to 300,000 tonnes stopped from getting into the river. There's a bit of inefficiency there, but that's unavoidable. Power consumption, so the operating is quite high. Operating cost is in the order of $10 million. The groundwater systems are very saline, so this is above 100,000 milligram per litre. The orange is seawater salinity and above. And so when we look at these schemes, the schemes are up through this reach of the river here, across here where we're between 14 and 35. These are all about 25,000 milligram per litre. And over here we've got, again, 25,000 milligram per litre water and getting a bit hotter through here. So the schemes are in locations where there's high salinity groundwater. I'll move on from this. And the groundwater flow lines you can see here are really toward the river, and in this reach here, all of the flow lines are converging on the river. So we're discharging into the river. This mound here is discharge upward from the underlying Renmark group into the Murray group and then into the river. So this is the Woolpunda reach, and that's a significant part of the interception scheme family. And where the other schemes are where, so it's gaining floodplains, where the floodplains are gaining water from both sides is where the schemes are located. Constraining the problem is the key to wellfield design. Look, I'm not going to, given the time, I'm not going to go through this a lot, but systematic data collection is important. The physical hydrogeology, the aquifer properties, the boundary conditions, systematic data storage, so you can get at it, and you know, in Australia, that's well organised on a state level. In developing countries, that data storage is probably a critical path activity to improve the ability to manage large-scale problems, improving the data storage, careful presentation of data, and analysis, analytical solutions, numerical models. Numerical models are useful, but they're not the only design tool. We don't rely on numerical models for the designs. We use numerical models to test our designs and maybe fine-tune them, but they are not a design tool. They're a quantification tool that we use on our designs. A couple of things that we do, you know, the logging. We logging each sample, taking photos of the samples as they come out. This is the Loxton Sands. Taking photographs of the samples is a good way to be able to compare from site to site and develop detailed conceptual models of the physical hydrogeology. What are the materials? How are they deployed through space, in cross-section and through cross-sections? So building up these detailed hydrogeological models so you understand what materials, and this one is about the materials, what are the materials the groundwater flows through? Where is it flowing? What's the salinity distribution in it? What's the relationship between these materials and the aquifer? How does the water get from the aquifer and the river? You know, what's that interface? Where is it getting into the river? Aquifer testing to quantify the aquifer properties. Done quite a lot of work in recent years on salinity in the groundwater salinity and changes in groundwater salinity. So it's probably, probably don't see this very often, but fresh groundwater coming from a flood, so we had a flood through here which put a lot of fresh water into the system, but once the flood receded at some relatively small period of time afterwards, August to November, the saline groundwater, which was always in this aquifer, this is from a well, a fully screened well, the saline groundwater in that aquifer returned and the fresh water sits on top. And this is a very robust arrangement. It's low salinity lenses are can be quite persistent. They don't mix, and the interface between low salinity and high salinity is usually quite sharp as this. We've been working on that in recent years. We've done a lot of work on in-stream on quantifying salt loads coming into the river, the spatial and temporal patterns of salt coming into the river from analysis of in-stream salinity data, both spatial and temporal data. We've become quite sophisticated with that, or the Murray Basin community's come quite sophisticated with that. We've made good use of geophysics, in-stream geophysics, particularly to pick up the salinity of the riverbed sediments, to identify whether we've got gaining stream conditions, salt coming into the river, or losing stream conditions where we've got fresh water going back into the aquifer. Airborne EM has been used to good effect, and we can see here fresh water in the blue, saline water in the red, essentially. So there's some, the AEM data correlates very well with all the other data and provides a really good data set, spatial data set to interpolate from bores. Groundwater models, yes, we use groundwater models. Use a groundwater model of the outputs from the Pike model, an important part of the toolkit that we use. I just want to, so I'm heading toward the end now, Trevor. Won't be in more than another 3 minutes.
Yep, that sounds good.
So we had this graph before, the salinity exceedances, and this was for 40 years of data. What I'm going to show you now is when we look at the data by decade, we see this pattern. So this is the blue is the 70s out here, and some really large exceedances all out here. The purple is the 80s. So in the 1980s, this is daily data at Morgan every day during these decades. In the 90s, we started, so Woolpunda was constructed in 1990, so it became operational in the 90s, and you can already see the pullback here. Waikerie was in 93, so some Mallee Cliffs was about 93, so a number of the interception schemes came on board here. And then in the noughties, from 2000 to 2010, the salinity was pulled back below 800 EC apart from one day. There was one day in that decade when the salinity exceeded 800 EC. We did, as a small exercise, we added back into this record the salt from Woolpunda and Waikerie schemes, which are only a quarter of the salt that's picked up, maybe a third of the salt that's picked up, and you can in the salt interception schemes, and you can see the dramatic effect that additional salt, if that salt were to be left in the river, the dramatic effect that has on the salinity at Morgan, and remembering that this is the water supply for a city of over 1 million people. So this would have had dramatic consequences for livability and water supply in Adelaide. So the salt interception schemes are sitting there churning away day after day. They are performing a fantastic job, and it's actually at the point now where people are forgetting that there is a salinity, that there was a salinity problem and there's a salinity solution. There isn't much visibility on the fact that there are ongoing efforts. There have to be ongoing efforts to maintain the control on the salinity in the River Murray. Look, low salinity lenses is a really fascinating sphere of work, and maybe we can talk about that in a later seminar. Particularly the interaction between and the controls on ecological process that are afforded by low salinity lenses, and so understanding low salinity lenses and then actively managing them is I guess at the frontier of salinity management these days, and certainly in my field. So yes, active management of low salinity lenses, which can extend to some distances from the river, can mean the difference between a landscape that looks like this and a landscape that looks like this. Look, thank you all for your patience. You've all been extremely patient. Trevor, Over to you.
It's been fantastic. That's a feast. I've never heard salinity so fulsomely put, and I've heard a lot on salinity science. So thanks very much, Andrew, and to Alison for
Yes.
beavering away. There's a ton of questions in the answered section. You'll see that Alison's been working on, and we appreciate both of you taking the time out of your day to do this. There's one question here from Karen Johnson in Western Australia. I think she runs a brilliant little consultancy called Managed Aquifers. I might not have the right.
Yes. Hello, Karen.
Yep. So you see her note there. How sustainable are these systems? I think that's referring to the SIS salinity inception schemes.
Look, sustainable is a very difficult word. You have to, in my view, you have to add a time frame to sustainable. It's how sustainable are they? No, it's not sustainable. It's a solution that will work for tens to hundreds of years.
Right.
But it costs. You got to burn coal or whatever power to run it, to make it work.
That's the other thing that comes to mind, actually. But I hear what you're saying about the window that we're talking about here of sustainability. We're not talking in 5 or 10 years. We're talking quite a long window. But the other thing was the energy. I mean, we're in areas where sometimes the sun is shining 300 days per year. So there is ample energy in the long run to keep them going for as long as they want to, I imagine. Anyway.
Yeah, the energy thing, you can't run them just off solar power. It is uneconomic to do that because you need to triple the size to your pipes to get the same volume of water.
Yeah. There's another question from Mari, then we'll leave it at that, I think. Lots of effort has been put into pumping out the saline groundwater. What other beneficial reuses of this water have been considered rather than infiltration and evaporation? What about treat for supply?
Yeah, correct. There have been things like fish farms. Fish farming has been trialled, not successfully at this stage. Manganese production, again, unsuccessful. I suspect that if we go through another drought that we might find more people interested in accessing that water. Desalination comes to mind.
This has been a fantastic hour, and you've done really, really brilliantly. Trying to put across 30 years of experience in 1 hour. It's humorous in a way to watch a man try and do this, and a woman. Thank you, Alison, to try and produce such amount of material in 1 hour is an absolute Herculean effort. Thank you very much for your efforts on this. And look, we're going to leave it there. We just wanted to say, though, there are a few free webinars coming up next week. It's all about water markets, and then we're on about coal mines and QGIS, spatial modelling for water modellers. There's a whole lot of coming. I won't go into each one, but do look on our website. There'll be a recording coming out of this webinar in the next few days, and we'll email that link to everybody. And also, there's a feedback form just comes up automatically on your screen when you finish. Spend just 1 minute, not even 60 seconds, and just tick the boxes and let us know what you thought was great and what you thought was hopeless. I think that's about it from me. Nothing else to add, Andrew. A final all up. This will get you through the salinity management problems for life. Nothing like that you can offer.
No, I don't think there is one answer.
No silver bullet. No. That's probably a good answer.
Careful work, analysis.
Careful and continuous. Thank you so much, Andrew. Thank you so much, Alison. Please do pass our great thanks to you, Alison, also for your help in this. And we look forward to seeing you again at the next webinar. And for now, we'll say goodbye. Thanks a lot, Andrew.
Thanks, Trevor.
Thanks for joining, Alison. Bye.
Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.